Okay, until that time, I have already calculated the circuit 2 program. So circuit 2, we start with the circuit analysis, and then we do the operation phasor circuit we did, and transient circuit, and also we did it for the waveform part circuit. Now the further application is that we will also circuit analysis utilized for the calculating the electronics and the power program. So the circuit 1 G48 that we focus on the power program, we utilize the doubling theorem, superposition theorem, Gaussian law to calculate voltage current, and also the circuit 2 is more emphasized in the control circuit program. So we already saw the frequency response, we already saw the transient circuit and switching circuit. We already finished the waveform calculation, gain, phasor calculation, we did it. Now today's lesson is that we will do the most calculation application of the circuit analysis in the multi-phase electronic circuit. So in the electronic circuit, the main thing is that we utilize the power amplifier. We amplify the voltage and the current and the power in the electronic circuit. So that we will solve the standard problem regarding that one. Okay, this is the program. Okay. So this is for the supply source VA is a 20 millivolt, and input resistance is a 10 kilo ohm, and output resistance is a R is a 4 ohm, and the output voltage is a 4 volt. So we have to calculate the voltage gain, input current, output current, current gain, output power gain, trans resistance, and the transconductance. Those things have to be calculated for this circuit. So firstly we calculate for the voltage gain. Voltage gain means the output voltage 4 volt, input voltage 20 millivolts. So the output by input voltage, so we can calculate voltage gain. We have to calculate voltage gain. AV is equal to the V out divided by V in. So V out is a 4. V in is a 20 millivolts. 20 is 10 watt minus 3. So the 4,000 divided by 20, so you get 200. Voltage gain you get 200. And B, input current. So input for the transistor situation, the input current can be calculated because of the voltage. So this one is a 20 millivolt, this one is a 10 millivolt. So 10 millivolt the voltage input is a 10. So the 10, so this is 400. And also that you can calculate for the current. Current across the amplifier is 10 millivolt, input is a 20 millivolt. So the voltage drop across the 10 kilo resistor is a 20 minus 10 because this is a supply voltage 20 millivolt, voltage across the amplifier is 10 millivolt. So 20 minus 10 millivolt across the 10 kilo ohm resistor. So we find the voltage drop across the 10 kilo ohm resistor. Voltage drop across 10 kilo ohm resistor. So this is the input is a 20 millivolt, output is 10, so you got it as 10 millivolt. Then we can find the current I. I is equal to the 10 millivolt divided by the 10 kilo ohm. So therefore that we calculate for the principle is 10 into 10 power minus 3 divided by 10 power 3. So this is 10 into 10 power minus 6, so the 10 microampere. So input current is 10 microampere. And then D. And then C, output current. Output current is a voltage is 4 volt, resistance is a 4 ohm. So you can calculate the output current. I out is equal to 4 volt divided by 4 ohm. So you call it 1 ampere. And then also you find that the current gain. The current gain means the output current by input current. So I out divided by I in. So the output current we already know the 1 ampere. Input current we already know that 10 microampere. So this is the 1 divided by 10 into 10 power minus 6, so this is 10 power 6 by 10. So 10 power 5. Current gain will be 10 power 5. 1 ampere, so 1 milliamp. Thank you. So this is 1 microampere. Thank you. 1 microampere. So this is 10. So this is 10 power 6. Current gain will be 10 power 6. So this is for the answer for E. And then E output power. So output power we have to calculate V out multiplied by I out. The body output will be the 4 volt. Current output will be the 1 ampere. So this is the 4 watt. And F. We also need to calculate power gain. So we have to calculate input power. So input voltage and input current. So the VA is equal to VA multiplied by IN. So voltage input power VA multiplied by IN you can calculate. So the input current is the 1 microampere. This is the input current. Input voltage is 10 millivolt. 10 into 10 power minus 3. Input current is 1 into 10 power minus 6. So 10 into the 10 power minus 9. So input power we got. And also that you can calculate output by 4 watt. So that then you can calculate the AP power gain. So AP can be calculated P out by PA. The output power will be 4 divided by 10 into 10 power minus 9. So 4 into 10 power minus 9 divided by 10. So that 4 into 10 power 9 or 4 into 10 power 8. So this is for the AP. And also we need to calculate the system. Transistor is the RE. The formula to calculate transistor is V out divided by I in. So the V out we already know that V out is a 4 volt. Input current I in is a 1 microampere. The 4 into 10 power 6 are ohm. So this is a 4 mega ohm. And then another one is the transconductor. Transconductor is the output current by input voltage. Transconductor. So in this case, I out divided by VA. So output current we already know that 1 ampere. Input voltage we already calculated 10 millivolt. So this is a 1 by 10 into 10 power minus 3. So 10 power 3 by 10. So you got 100. So calculate the transistor we can calculate by this way. So this is for the typical case of the power amplifier calculation. So the very formulas are the voltage gain, output voltage, input voltage. So by this way we measure the output voltage, input voltage, so we divide. And then we have to find the input current so that VA is 20 millivolt, voltage across the amplifier is 10 millivolt. So the difference 10 millivolt across the 10 kilo ohm resistor. So that this voltage divided by 10 kilo ohm resistor, so we got the current. Current gain formula will be the output current by input current. So output current is the 4 ohm resistor connected across the output, so that the voltage across the 4 ohm resistor is the 4 volt. So this 4 volt divided by 4 ohm resistor, so output current 1 ampere. Output current 1 ampere, input current we already know that 1 microampere. So then you can find the output by input current ratio, so you got the current gain. Power output is the output voltage and output current. So output voltage is the 4 volt, output current 1 ampere, so you got the 4 watt. And power input voltage and input current. Input current is the 1 microampere, 1 multiplied 10 power minus 6. Input voltage is 10 millivolt, 10 multiplied 10 power minus 3. So by multiplying, so 10 into 10 power minus 1 watt. So this is input power. So the ratio between the output and input power is 4 into 10. 4 divided by 10 into the 10 power minus 9. So that you got the 4 into 10 power 8. So this is the AB. Transistor formula, output voltage by input current. So output voltage 4 volt, input current is 1 microampere. So you got a transistor. Transconductor is output current by input voltage. So output current is 1 ampere, input voltage 10 millivolt. So you got a transconductor is 100. So this is the way that we solve this problem to find the voltage gain, current gain, power gain, and transistor transformer. This is the equation to calculate the voltage gain and the current gain. So, firstly, the voltage gain in the dV. AB in the dV. Tell you the formula AB dV is equal to, the formula is 20 log 10 V2 by V1. Therefore, now we can see that V2 by V1 is equal to 10 power AB, so 10 power AB dV power 20. So this is V2 by V1. So V2 by V1 is also that we can use the AB. AB is 10 power, AB is dV by 20. So this is the way you can calculate. And similarly, say dV total. dV1 plus dV2 plus dV3. So this is that we can calculate for the AB dV by this formula. Okay, so this circuit, we have to calculate for the total gain, total dV. So total dV is the sum of the all dV. So sum of the all dV. So each of the stage, they are losing the gain. First stage, the input loss is minus 6 dB. The amplifier stage loss is 40 dB. Tone control loss is minus 14 dB. Main amplifier is 20 dB. So by this way, now we can find out how much total dV. So total dV you can calculate dV total. So this is the input is a dV1, 2, 3, 4. So we calculate dV total is equal to dV1 plus dV2 plus dV3 plus dV4. So the input dV is a minus 1, minus 6. Plus dV2 is a 40. Plus dV3 is a minus 14. Plus dV4 is a 20. So by solving this all the same way the 40. So this is for the dV total we got. In the meantime, we also have to calculate the voltage gain in the ratio. So ratio means dV total you can add AB total is equal to the AB1 multiply AB2 multiply AB3 like this. So this is for the answer for the total gain dV. dV total is dV1 plus dV2 plus dV3 plus dV4. So then we call it total decibels gain. And also the direct gain means that you have to multiply. Multiply the AB1, AB2, AB3 like this. So for the answer AB total is equal to AB1 multiply AB2 multiply AB3 multiply AB4. So we substitute here. So AB1 is a 10 power AB dV. So this is a 10 power AB1 dV. Multiply 10 power AB2 dV. Multiply 10 power AB3 dV. Multiply 10 power AB4 dV. So we substitute here. 10 power AB1 dV is AB1 is a minus 6. dV, so 10 power minus 6. So this is by 20. So 10 power minus 6 by 20. Multiply AB2. 10 power. So AB2 is here, so this is 40. 10 power 40 by 20. Multiply 10 power AB3 is minus 40 by 20. Multiply 10 power 20 by 20. So by this way, you add the same all the same. So then we just 10 power minus 0 by 3 multiply 10 power 2 multiply 10 power 0 by minus 0 by 7 multiply 10 power 1. So you add all the 10 power minus 3 plus 2 10 power minus 0 by 3 plus 2 plus minus 0 by 7 plus 1. So then we 10 power 2. So then what I do is 100. So this is a total AB we can calculate by this way. And then we also need to calculate for the input voltage. So input voltage of main amplifier. So main amplifier input voltage you have to find this is dV. AV. So this is this AV. AV 1, 2, 3. So that we also have to calculate the speed. AVs are 1, 2, 3. So this is a 10 power AV 1 dB by 20 multiply 10 power AV 2 dB by 20 multiply 10 power AV 3 dB by 20. So that we substitute to 10 power minus 0.3 multiply 10 power 2 multiply 10 power minus 0.7. So by solving this one, you can call the thing is this is a 10. So this is 10 power minus 0.3 plus 2 plus minus 0.7. So this is 10 power 1 is a 10. So this is for the as you just say. So the main amplifier is a this is for the VN for main amplifier. So this for the input, this is a VN. So this way, so that we can calculate. So VN for the main amplifier is equal to VS multiply AVs are 1, 2, 3. So VS is we already know that VS will be the 100 millivolt, 110 power minus millivolt. AV 1, 2, 3 we already got a 10. So that will be 110 power minus 3 multiplied 10. So by solving this one, you got the thing will be the 10 one more. So this is for the input for the main amplifier. And the output voltage of the amplifier. So we also have to calculate for the output voltage, Vout. So this is for the authority. And the Vout. So Vout can also be calculated. We have to calculate Vout. So this is for the VMA. So VMA multiplied by the AV4. So this is the AV4. So this is the VMA is the 1 volt. AV4 is that we can calculate the 10. So this is 10 power AV4 dB. Divided by 10. So this is the 1 multiplied 10 power AV4 dB is the 20 by 10. So this is the 10 multiplied. So 10 power 2. So this is a 1 volt. So this will be the 100 volt. So 20 by 20. So this is for 20 by 20. So this is a 10 volt. So this is the we calculate for the amplifier. I is a 1 kilo ohm given. And then the amplifier input resistance is 4 kilo ohm, voltage is 100, output resistance is 100 kilo ohm. Load resistance is 300 kilo ohm. So this is a given. So normally we can draw the amplifier circuit like this. Amplifier. So amplifier we can draw the equivalent circuit diagram. So amplifier this is the equivalent circuit. This is input resistance RI. Across this one and signal source. Signal source is AV multiplied VI. And this is output resistance RO. Put it like this. So this is the VI. So this is the VI. So this is the equivalent circuit of the amplifier. If you see the amplifier, we can draw the equivalent circuit like this. Input resistance, input voltage. So input voltage is multiplied with the voltage gain, and then output resistance is series, and we supply to the VR. So the amplifier space that we can represent by that kind of circuit. So now that we draw a circuit here, so resistance and the source voltage. So source voltage is 100 millivolt, source resistance is 1 kilo ohm. The signal source, amplifier, and the load are in series in the gate proper 3. So the source resistance is VS is 100 millivolt, RS is 1 kilo ohm. So that we can calculate the VS 100 millivolt, RS 1 kilo ohm. So input resistance RI. RI is a 4 kilo ohm. Output resistance VI. AB into VI. So AB is, we already know that this one. AB into VI. So AB is, we already know the 100. Multiply VI. So how much of the body across the distance? The resistor. So this will be the. So AB into the VI. VI is this is the we don't know about the VI, just leave like this. And our R0 of the amplifier is 100 ohm. And then this is low. Low RL is a 300 ohm. So this is for the equivalent circuit diagram for the amplifier. Okay, so this amplifier input voltage is 100 millivolt. So this is the VI across here. And this one is output. Okay, we can find a VI. So VI can be calculated. VI is the input voltage for the amplifier state. This is the amplifier state. So we can find a voltage in VI because we can utilize this voltage divider diode. So that 1 kilo ohm RS and the RI 4 kilo ohm are so that in series across the VS. So that you can calculate the VI. So VI you can calculate. VI is equal to VS multiply RI divided by RS plus RI. So we got. So VS is 100 millivolt. RI is 4. RS plus RI is 1 plus 4. So you got the find solving this is 100 multiplied 4 divided by 8. So you got this 80 volt, 80 millivolt. So this is the VI we got. And after that, so we already got input voltage for the amplifier. So this is what is so answer for A is this one, and this is the answer for B. And answer for C. Determine this output voltage of the amplifier. Output voltage is AB multiplied VI. So this is the VR. AB multiplied VI. So AB we already calculate 100. VI is 80 millivolt. So 80 into 10 power minus 3. So 80 into 10 power minus 3. So you got the output with the 8 volts. And then determine the voltage gain of the amplifier. So this voltage gain, we always have to calculate VI. So this voltage how much are voltage? Output and the input. So output voltage we calculate by this way. So voltage gain is a AB we already know AB is 100. So this is what B is 100. And the E. So this is what output determine output voltage transformer. Okay. And determine the voltage gain of amplifier to achieve the tempo across the load. So in this case, we have to calculate the tempo across the load. So in this case, output voltage, VR is the tempo, okay? Vn. Vn we already know already for here, Vn is equal to the 80 millivolt. So that we have to find the AB. So VR times the Vn. So the 10 divided by 80 millivolt into 80 to 10 power minus 3. So by solving this about 1000 divided by 80, which is 0.5. So there will be the voltage gain. Amplifier calculation. So we utilize the amplifier circuit, amplifier gain, amplifier input, output, amplifiers are equivalent resistance, and we solve that kind of circuit problem. So this is for the application of the circuit analysis in the power amplifier calculation. So that this circuit one is mostly the power circuit. We did the Starcher law, superposition, leveling, and the circuit tools we focus on the more electronic circuit, signal circuit. So signal circuit, electronic circuit, we did the transient circuit, phasor circuit, and also the path circuit. Today we do that for the electronic circuit. The next program, so this is a typical circuit from the microphone, the pre-amplifier state amplify it, and then the main amplify again, and there's a loudspeaker being driven. So this is the base argument. So when you draw the equivalent circuit, when you calculate the input voltage of the pre-amplifier, input voltage of main amplifier, low voltage, and the output power, those they have to be calculated. Okay, first step we have to draw is a equivalent circuit. So microphone is a voltage source and a current source. So this is voltage source VS, the 3 millivolt, and this is for the resistance RS, the 1 kilo ohm. So pre-amplifier state. So then we the input resistance RI. It's a 10K. And then this is for the this is AB into RI. AB into the VI. So this is a VI. AB into VI1. Multiplying with the output resistance is a R0. 2K. So in this case AB is 100. Multiply VI1. So this is what is a pre-amplifier. And then the main amplifier also we can draw. So input resistance here, input resistance RI, 60. And then we can also draw this one, the voltage source, so that this is the AB into the, this is the VI2. So this is AB into VI2. So this is AB into 20 into VI2. So then we get our output is the R0 is a 2 ohm. So this one is our main amplifier. And then this one with the loudspeaker. So loudspeaker is a 4 ohm. So this is for the circuit configuration of the this capacitor amplifier, pre-amplifier and main amplifier. We can call the circuit like this. Okay, the first thing that we have to calculate the input voltage of the pre-amplifier. So this pre-amplifier input voltage VI1 need to be calculated. So this is for the first one is the answer A. Answer A we just draw the equivalent circuit diagram. Answer B, we need to calculate the input voltage of pre-amplifier. So that we have to calculate VI1. So we calculate VI1 is equal to VS multiply RI divided by RS plus RI. So the VS is a 3 millivolt divided by RI is a 10 kilo ohm divided by RS plus RI is 1 plus 10 kilo ohm. So by solving this one, then we be that 2 by 72 millivolt. So VI1 we can calculate. So this is for the answer of B. And also we need to calculate input voltage of the main amplifier. So before you calculate the main amplifier, we have to calculate AB into VI1. So that this one with the AB into VI1 we have to calculate. So this is 2.72 multiplied by 100. So millivolt into multiplied by 100. So that one we calculate is that 272 millivolt. We got. Okay, this millivolt is here. So AB into VI1 is connected across the R0 and VI2. R0 and RI. So we can calculate VI2. The formula is that VI2 can be calculated. So AB into VI1 multiply RI divided by RI plus R0. So therefore the AB into VI1 you already know that 272 multiplied RI is a 6 divided by RI plus R0 is 6 plus 2. So we got. So by solving this one, what you call it, this is 204 millivolt. So VI2 is a 204 millivolt. So this is for the voltage input of the main amplifier. So this is the answer for the C. And the D, low voltage. Low voltage is this is the VAS here, low voltage. So to calculate low voltage, we also need to calculate AB into VI2. So we calculate AB into VI2. So AB is at 20 are doing that 204 millivolt. So the 20 multiplied 0.2044. So this is multiplied, so this is a 4084. So 4.084 we got. Okay, this is for the AKB and then low voltage VI you can calculate. So now the low voltage VI is equal to AB into the VI2 multiply with RN divided by R0 plus RN. So this is a 4.08 multiplied RN is a 4 divided by 4 plus 2. So 4.08 divided by multiplied 4 by 6. So 16.32 by 6. So by 2, so 43 is 2 by 7 the volt. So this is for the output voltage we got. And then also you have calculated the output power. So the VR. So this is a VR square divided by RL. So VR is a 2 by 7 square divided by RL, which is a 4. So 2 by 7 into 2 by 7 divided by 4. So we got the output power. Okay, so this is the data that are given. So this is for those data we get from the predicate. So we use the amplifier and we measure the input current, input voltage, and then we record the data and we adjust the frequency and we record the data. Those information. So those things are we got from the amplifier. So what you have to do is that we need to plot the frequency response characteristic. So in this case, our frequency is set from as a 10 hertz, and they increase up to the 1 megahertz. And the input voltage VI is at 100 millivolt, output voltage VO is 1 volt. So input and output voltage we measure, and then we put on the data statement. Okay, voltage gain we can calculate. Voltage gain is output by input. Output voltage 1 volt, input voltage 100 millivolt. So we can calculate 1 divided by 100 into 10 power minus 3. So this is for the 10. Voltage gain dB. dB means that we use 20 log 10. Output voltage V is 1 divided by 100 into 10 power minus 3. So by forming this one way is 20. 10 ohms are low power. Output voltage square divided by 10 ohms. So output voltage we already got 1 square divided by 10. So this one we got 0.1 watt. Power gain. Power gain is base power. Power as low divided by base power. So this is a 10 law. Power as a low. Power as a low is we calculate 0.1 megawatt. 0.1 watt and the base power is also is 1 milliwatt. 1 into 10 power minus 3. So to by this way the power gain we got is 10. So this is the formula we calculate. So similarly
we use the two formula to calculate for the frequency VI, VO, voltage gain, dB, low power, and also power gain. So then we calculate, put in the table, then we plot the graph. Graph means the horizontal graph is a frequency, vertical graph with the voltage gain, power gain, dB, so that we can plot the graph like this. And based on here, there will be another 2 more programs the calculation that provided. So there will be this will be the equation. So there will be problem 6 and problem 7. I have already provided the equation, so you look at the thing. So there will be the audio signal generator whose source circuit resistance is a 600 ohm. Is connected to a amplifier which has a 3 kilo ohm input resistance and 1 microfarad coupling capacitor. So those are the given. So we have to calculate the low half power frequency. So in this case, FL 3 dB. So that equation is 1 divided by 2 pi RS plus I multiplied by C. So we substitute the RSI value, then we can calculate the FS 3 dB frequency. Also, another problem is that amplifier has the input impedance 10 kilo ohm. Calculate the value of the coupling capacitor required for the 40 Hz lower minus 3 dB frequency. So in this case, so resistance is 600 ohm. So we also substitute F at 3 dB equal to 1 divided by 2 pi in the bracket Ri plus Ri Rs into C. So in this case, F at 3 dB is 40 and Ri is 600 ohm, Rs is 1000 ohm. Therefore, here you got the capacitance. So the capacitance is 2.486 microfarad.